Hi everyone. Today I'm going to teach you NumPy. It's a package in Python which gives us the APIs or the functionalities related to array related operations. So basically NumPy stands for numerical Python. It is used for computation and processing of multidimensional array. So you can ask, why do we need array when we have a list, right? So when it comes to representation of data in terms of list, it is not efficient in terms of storage or operation. So we can represent any data, whether documented data or visualized data, in the form of numerical array or in the form of matrix. Okay, so NumPy provides the efficient way of storing the array elements, or even it provides functionalities using which you can perform a lot of operations on array efficiently, which you cannot perform on list. So I will give you some examples using which I will write a code for using NumPy and array, and you can see how many bytes of space does the list occupy and how much bytes of space the NumPy occupies. Okay. So NumPy is written in C. So any code written in C takes less operation time, and the code is written internally. Okay. So we can do data manipulation operation using NumPy. So let me write a program in using loop in Python, where we can see how much space does the list takes for storage. Okay, so let me import this lst is equal to list of range of 1,000. So let's print sys dot get get size get size of lst. Okay, so let me print this. Okay, so this takes 8,056 bytes. Okay, so now let's compare this with the numerical Python. So before using NumPy, first we have to use pip. We have to install NumPy. Okay, so first we'll write a command pip install NumPy. So let me tell you about this pip. So pip is a tool using which we manage packages and modules in Python. If you want to download or install any package in Python, any package of Python, you can use pip install to download that package. Okay, so it says that requirement already satisfied. NumPy is already installed in my system. If it is not installed, please go and install using this command pip install NumPy. So now let me write a code. Import NumPy as np. So I have given areas as np. So let me take a variable name array1 is equal to np dot array of 10. Let me let me create a list here first, or otherwise let me take the previous list that is already created. So np dot array of lst. Okay, now check the size the array takes. Okay, so you see here this code, the list is occupying huge space, compared to NumPy. Okay, so when you're coding in, uh, uh, I would like to say why NumPy takes less space because NumPy is written in C language. Okay, so as elim and C language, you know that it is faster. It takes less time to process, and operation wise also it's faster. So this because of this reason, the the list is not so uh, uh, compatible, I would say, or I would say it's not so efficient. So list is not so efficient compared to array. As elements increase, array takes less memory compared to list. And operation wise also, arrays are efficient and much more faster when compared to list. Since NumPy is written in C. Now let's start creating array using NumPy. So let me choose Markdown option over here. Markdown. Okay. Okay. So we have imported NumPy as NP over here. Okay, let's import it again over here. Uh, Import NumPy. It is not required to import again, but I'm just importing because I'm starting the coding of for NumPy from here onwards. So let's create an array with an element 10 inside it. So array1 is equal to np dot array of 10. So print arr1. So here 10 is an array. So if you want to check the data type of this, you can write the type, type of arr1. So you can see it's ND array, showing n-dimensional array. Okay, this is this is one-dimensional array. So let's now uh, print some. Let's now add some more elements into the array, or let's add a list into the array. Okay, so array1 is equal to np dot array. Now let's pass a list inside an array. So uh, print array. Okay. This is printing it as an array. Sorry. Let me see what's the mistake here. Okay. So this is array of list. Let me check the data type of ARR1 now. Okay. So this is a list of array. You can see here the class ND array. Okay. Now what we'll do, we will create a list array of tuple. Let's copy the code and let's create an array of tuple. So we have now created an array of tuple over here. Let's create an array of string. Let me copy this code again and pass string inside that. String inside np.array. So now when you print it, it shows an ND array and we have created an array of string. We can see the type of array of uh, string is ND array. Okay, let me check. ND array. Okay, not a problem. Now let's create an array of dictionary. So we are now creating an array of dictionary. Let's pass a key value pair inside the dictionary, inside the flower bracket, is 200. Yeah. Okay. So there is some mistake. Let me check. Yeah. So we have not declared variable over here. Okay. So we have the array of dictionary that is printed now. So so now let's move to the new concept. So the core data type in an array are integer, complex, float, and string. Strings are represented by U6 or U8 Unicode representation, and apart from this, they apart from this will become object data type. So what I mean is that the core data types are integer, complex, float, and strings. Okay, and other than these data types like dictionary and tuple, set, list, these are derived data types. These are considered as object data type in array. Okay. So now let's create 1D array, creating 1D, one-dimensional array. Okay. Now let me mark down this. Okay. So now let's start with creation of one-dimensional array. So we have already seen some examples of one-dimensional array. Let's check the data type for each of that. So let's create, so what we can do is that let's check the data type here, print arr1 dot d type. This is int32. So similarly, let's print arr1 for d type over here. So this is also int32. Let's print over here. So this is also int32. Let's print over here and check. Yeah, so U6, you see here, we are getting a U6 right over here. So U6 and U8 Unicode representation are for represented for string. Okay. So and let's see if what we get over here. So array1 dot d type over here. So you see, if you see, there is an object data type that is mentioned over here, but this is because other than the fundamental data types like integer, complex, float, and string, all other if derived data types are considered as objects in NumPy. Okay. Okay. Let's check the. Let me copy this code. So let's check the shape of this array1 dot shape. Okay. So this is a shape which the output is 3 comma, since it is showing number of rows and columns. Okay. So let me see the size of this array1 dot size. So it's 3. So it is showing the number of elements that are present in the NumPy array, in the array IRR1. Okay. So now let's see what is the dimension of this array. we can check this by using the command arn.n dimension in the. So this is a one-dimensional array. So now let's create a two-dimensional array. So I'm going to create a two-dimensional array now. So arr 3 is equal to np dot array of, let me take a two-dimensional array, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8. So have a two-dimensional array over here. Okay. So now we check the dimension of this array using n dimension command. So this is a two-dimensional array. So let's see the shape of this. So this is okay. Let me check. Yeah, sorry, error 3 dot shape. Okay, so this is a two row and four columns are present. You can see here. So now let's see the size. Size gives the total number of elements that are present inside an array. Okay, okay. So now let's check the data type of the array. Okay, this is an integer data type. Okay, so now let's create array using some built-in function. So array creation, let's give it a heading as array creation using a built-in, let's write using built-in function. Okay, let me mark down this. Okay, so what happens usually is upcasting in Python from bottom to top. So I mean, so if let's consider you are having an array which is having heterogeneous data types like int, float, and string. So what happens is that if you are having heterogeneous data type, then all are converted into homogeneous by upcasting it to the higher data type. Let me give you an example for this. So let me write this upcasting in Python from bottom to top. So higher in the higher level we have object. Object in the sense it can be list, dictionary, a tuple, and below that it is string. So if you have a data type containing string and object, all the data types will be converted from string to object. This is the property of array. Array can only contain homogeneous elements. It cannot contain heterogeneous elements. So below string is complex, and below the complex we have float, and below float we have int. Okay. So now let me give you an example. Let me take this. mm, Let me take this array. Okay, so now let me add some more elements into it, 40, and let me add a string. Let me add a floating value, 40 point. Okay. So now when you print this array, you can see here, you have passed integer values 10, 20, 30, and 40. And let me change it to 50. So you have changed the 10, 20, 30, 40 as integer array, and you have passed 50.0 as a floating value. So what happened is that your int values is upcasted upcasted into the float values. That is, this is what upcasting does. Upcasting in Python happens from bottom to top. So now let me give you another example. Copy this code and Let me convert this to string. So now check. Now all the data type, all the elements inside the array has converted to string format. Okay. So this is what happens. This is what upcasting does. So let me take more examples for this so that you can understand better. So let me convert this to uh, a complex value. Okay. A complex value. So let's see what happens. Okay, see, you can see that all the elements inside an array, inside the array has been converted into the complex format. Okay, so now let me use this and try to convert it into. Let me pass tuple of value. Let me pass a tuple over here. Okay. So what happened is that ignore this warning sign. So you can see that the data type here is an object over here now. Okay. So what it is saying, the warning sign creating an ND array from rag nest sequence, which is a list or tuple of list or tuples, and it is duplicated. If you just can ignore this, but you have can see that now the data type which is showing is an object. Okay, it's an object. So let me consider some more examples if you want. Um, so let me consider a list elements with the dictionary. Okay, 40 contains 400, comma 50 cake has 500. Okay. So let me see, if you can see here, the data type is an object over here. So what happened here is that whatever data types you have, it is upcasted into the higher data types so that list property of homogeneity can be restored. Okay. So now I'm going to teach you some different topics related to scikit image. So let me import sk image from sorry from sk image. Let's import some data image import data. And also, this SK image is a scikit image. Let me go to Google and check it. Okay, so let it take. So, along with this, let me import a data visualization library also. So, we use the data for data visualization. We use matplotlib and cbon. Let me use matplotlib for this plotting. So command is matplotlib.pyplot. So let me give it an alias as plt. Okay, so let me go to this scikit image. So you can see here in the scikit image, if you go to the gallery and in the general purpose images, if you go, you can see these are the commands. So import matplotlib pipeline. So this was for the data visualization. We use matplotlib, and this is for numerical Python for doing operations and array. So these are the data we have. So let me take one image from here. So from sk image import data, that operation I have done. So let me run this code. Okay, let me see what all images are there inside this. Okay, we have astronaut image, we have a coffee image. Okay, so let me take this rocket image over here. Okay, so go to Jupyter Notebook. So write rocket is equal to data dot, what is the, this is rocket, right? This is rocket. Yeah, rocket. They write data dot turbo security rocket. And after that, print rocket dot size. So this shows the number of array elements that are present inside this image rocket. It includes both horizontal and vertical image array elements. So let me go and check the shape of this rocket. Print rocket dot shape. So the shape is, there is 427 rows, 640 column, and along with that we have three. These three represent RGB, which is red, green, blue color. So if you had black and white, you would have one. But since it's in RGB, we have dimension as three over here. So let me show you the plot of that rocket. So we can implement that. We can visualize that using the command plt.im shows, where plt is the matplotlib .pyplat alias. So we will pass rocket inside this. Okay, so you can see the visualization over here. We have, these are the rows and these are the columns over here. Let me try to access only rocket from this image. Okay, so you have this array, right? Let's consider, let's see, this value starts from around 125. Okay, so let me write plt dot I am show of rocket. So we have to pass index. So we have three index x, y, and so in the x, in the row column, we have to pass from 125, I guess. So from 125 till 400, sorry. So we have to pass from 125th index till the 400th index, 450th index here we can pass. And this is the 125th index here. And this is the 450. We want just rocket from this image. We are trying to extract only rocket from this image. So let me pass the column. So column value is somewhere around 300 to 300 to 350. Let me pass 300 colon 340. I will pass 340, and we are trying to take all from the last row. Okay. And for RGB, we are extracting whole everything. Okay, so now we have extracted only rocket from this image. This is how we can do index operation on an array. Even though this is an image, we can perform operation on this image as we used to perform in our numerical Python. So now what we do, let's now we see array creation using built-in function. Okay, array creation function. Okay. So now let me create an array with a built-in function. So we have a built-in function called arange, just like a range function we use in Python. In numerical Python, we have arange function. Okay, this is usually used on arrays. Okay, so we have created an array of elements from 21 till 30. But the difference between range and arange function is you can even use range function over here, but the difference is with range, you were not able to get the floating point numbers. I mean, you cannot give a step size of floating point, but this is not possible in respect to a range. You can pass a floating point. I mean, with the step size, you can pass in decimals, which is not possible in case of a range function. Okay, so let me pass a step size of zero point 0.5 over here. As you can see, we have got the step size of zero point 0.5 here, but this was not the case with the range function. You can go and check. If you want, I can show you that for I in range of 1 comma 100 comma let me take 10 comma 0.5 print I. See, float object cannot be interpreted as an integer, okay? But if you just go and use np dot arrange over here, let me check what happened. Okay, np dot arrange. See, you are getting the floating point number here, but this was not the case with range function, okay? Okay, now what we do is that, so we'll see some more built-in function, like we have built-in function called reshape. So what reshape does is, let me take array4 is equal to np dot, let me take this. So let me reshape this. Reshape of 4 comma 5. Okay, so this is not, we are not able to reshape because we are trying to pass 4 rows and 5 columns, which is total 20 elements, but here we are not having 20 elements, we are only having 18 elements. So let me try once again with giving the 31 over here, upper limit as 31. Okay, so now we will print it. Okay, now. So you can see that we have got the array of 4 rows and 5 columns using a built-in function called reshape. So let me use another built-in function called as linspace. Okay, so R5 is equal to np dot linspace of 21 comma 31. Let me give the lower limit 21 and 31 and give the steps like. So what happens in linspace is that, so your lower limit and upper limit will be included, and it will try to divide in step of 10 elements in such a way that all the elements are are in equal proportion. I mean to say, if you print this, you see the lower limit is 21 and upper limit is 31, and you can see that you have tried to take 10 elements between 21 and 31. So linspace, what happens is that in linspace, start and stop is inclusive. Okay, start, stop, and the number of elements. This is like, I can say this like, let me write this. This is like start, stop, and number of elements that you want in that range. Okay, so here you will see, here you will space the number of elements you want. So you can just check with by giving it as number of elements you want between 21 and 31 is 20, and this 21 and 31 is inclusive, and it will make sure that equal division happens in such a way that there are 20 elements that is printed between 21 and 31. So let me print ARR5. Okay, so you can see equally proportionate the division has happened. So now let me go and use some other built-in functions like zeros like, and also ones like, and I can also use a empty built-in function or EYE. These are the functions that will generate specific kind of array required for array manipulation or matrix of manipulation. Okay, so let me show you that. Okay, so now np dot zeros, the ros zeros will print. Let me print zeros with 3 rows and 4 columns. Okay, we have got zeros with 3 rows and 4 columns. You can see the data type is here is in not integer, it is float. Now let me print zeros like let me print zero. You let me use the built-in function zeros like now instead. Zeros like array of let me pass this array. Okay, let me pass this array and check what kind of answer I get. So what happened here is that so we have got 20 elements since we had let me instead pass this has five equal to this thing. Yeah, RR5. Okay, so what happened is that we have created a array of zeros just similar to ARR5. Okay, so we initially before that we passed this array 5. So whatever elements was there inside that, it was replaced by 0 in that place. Okay, so now we will see other built-in function like ones, and let's pass 3 comma 4 as the row and column. So this is what we get in ones, and similarly ones like is np dot ones like, yeah, rr fine. Okay, so I have passed this is zeros, but all the zeros has been replaced by ones over here. Now let me use the empty function. So empty function creates an array with empty values or garbage values. Okay, so let me write np dot empty of 3 comma 3. So you can see some garbage values has been inserted inside this array. If you run once again, let me run this here. Okay, so but these are the garbage values. Okay, there is no point, there is no sequence that is present inside this. So let me pass in 3,4 now. Okay, and p dot empty. So I got some garbage value here. Let me pass 3,3 now. Okay, so this is how we are getting some unwanted garbage values by using the function np dot empty. So, just like identity matrix in mathematics, we have an operation for identity matrix creation using the command EYE. EYE function gives you an identity matrix. So you just have to pass one value, pass a matrix value since rows and columns are equal for an identity matrix. So you can see we have 5 rows and 5 columns, and the diagonal elements are all 0 over here. So now what we do is let's reshape an array. Okay, reshape an array. So let me mark down. So reshaping an array using reshape function, we can reshape the array. Okay, so we have seen already the reshape function, but what is different now is, let me show you. npr. Let me create a linspace elements from 21 till 31, and I want 50 elements between 21 and 31. So let me reshape this into reshape array reshape with 10 comma 5. Since I have 50 elements between 21 and 31, I am going to reshape with 10 rows and 5 columns. Right? So I have 10 rows and 5 columns over here. So what I will do here now is I will try to reshape in such a way. Let me take the same code here and write that I will try to reshape in such a way that I want 10 columns but any number of rows. Okay, I want 10 columns. So how many rows we will get now? Since 50 elements are there and we have 10 columns, now we will get 5 rows. We need to get 5 rows, but you don't have to pass here the number of rows. Either you can pass number of rows or the number of columns that you want, and it should be in such a way that it is multiple of 50. Okay, so let me pass this. So you can see now we have got 10 columns and we have got 1, 2, 3, 4, and 5 rows. Okay, so similarly you can do this in the opposite way. Control V. I want 5 columns and any number of rows. Okay, so this will give 5 columns and 1, 2, 3, 4. Sorry, 5 rows. Sorry, it is 5 rows and any number of columns. Let me change it to 10 rows. So let me change it to 10 rows. Okay. Okay, so now I got 10 rows and multiple of 50 is 5, 10 into 5. So if I got 5 columns, you don't have to pass this. Okay. The second argument is not required. Either you just pass one argument with rows or you can pass an other argument with columns. You don't have to pass both the arguments. Okay. Okay. So there is shape attribute. Okay. Other than reshape, there is a shape attribute that I wanted to tell. So shape attribute will make changes to the existing array. Okay. So number of repetition, what we have to pass is number of repetition, rows and columns we have to pass here, like number of repetition, repetition, comma rows, comma columns. So this is the syntax for a shape function. So let me go and write array5 dot shape. So let's not pass the first argument. Instead, we will just pass -1 as the first argument. I will need 5 rows and 5 columns. So what happens? So we have 50 elements and 5 cross 5 is 25. So obviously we have to get 2 as the number of repetition. Let's see what happens now. Let me print arr5. Yeah, you can see that we have 2 repetitions over here, and see one. We have this is first row, second row, third row, fourth row, fifth row, first row, first column, second column, third column, fourth column, fifth column. Okay, and you can see we have 2 repetitions. So one, this is the one, and this is the other. So it has created 2 repetitions of 5 cross 5. Since 5 cross 5 is 25 and 25 into 2 is 50, so we have 2D array of 5 cross 5 matrix of total 50 elements. Okay. Okay. So let's now move to the reshaping of an array using the transpose of a matrix. Okay. So let me check with the transpose. So you can reshape an array by transpose of a matrix. So let me write an array of elements. Let me pass now array of string elements instead of integer elements. So now let me pass UK, USA or UP or HP. So now other array is MP, comma K, comma AP. Okay. So now I have a string elements with 2 cross 2 as the matrix shape. So we can transpose this matrix. We can do this using operation like AR dot sum or T. This is the command used for transposing array. Okay, this is an LB for this is a function used for array transpose. This is converting rows to columns and vice versa. You can see the rows have been converted into columns and the columns have been converted into rows like UKMP, UPK, and HPAP. Okay. Similarly, the transpose operation can be done using the built-in function in NumPy, like np dot transpose of ARR7. So you can see the transpose operation happened once again using the NumPy inbuilt function. So now let's see some other inbuilt functions inside uh, array operation, the some of the inbuilt functions that are present inside array. So we can convert an array or we can flatten an array like we have let me use there is ravel and flatten function which that can flatten infinity flatten an array. So revel is defined inside NumPy. Revel is defined. This is defined inside NumPy function, and flatten is defined inside array. Okay, this is inside array. This is defined, and this is NumPy. Let me show you. So print arr 7 dot revel. Okay. Similarly, I will use np dot flatten of arr 7. Okay, what is the problem with this? Okay, so sorry. Flatten. This is also able. Okay, you can see flatten able. You can flatten uh, using a Ravel function that is present both inside uh, NumPy and as well as array. But let me check. Actually, flatten is defined inside the array. Okay, so let me check with that 7 dot fft. Okay, so this operation happened because it's a NumPy array, right? Okay, so we have an inbuilt function inside an array that is flatten, which is used to flatten the array from multiple dimension into a one-dimensional array. Okay, now if you want to check what are the built-in data types, built-in functions that are present inside array, so you can check here. These are the built-in functions that are present inside the array. So let me check where is flatten inside this flatten flat. Yeah, okay. So here you can see the flatten function. So this is the flatten function we use to flatten from multiple dimension to single dimension. Similarly, you can check the directory inside that NumPy. So what are the built-in function inside NumPy? So let me check where is reveal. Okay, this here is the reveal function that it is used for flattening the array. So now let me do the basic operation on an array. Okay. So the basic operation on array. Let me mark this down first. Okay. Let me create two arrays. Array one contains elements 10, 20, 30, 40, 50. And let me create another array called with a variable name identifier two array of 11, 22, 33, 34, 55. Okay, so we have created two arrays, array 1 and array 2. So let me perform some mathematical operation for this two array. So let me perform addition of these two array, here are 1, here are 2. Similarly, let me copy, paste, and let me perform subtraction of two array. Error minus error to 2. Let me perform multiplication of two array. Let me perform division of two array. Let me give ARR2 over here, ARR1 over here. Let me perform modulus operation on the array, which gives the remainder. Let me perform a square root ARR2 to the power of ARR1. Okay, so these are the some of the mathematical operations that can be done. We have another double modulus quotient. For getting the quotient, we from AR2 double slash ARR1. So this will give quotient or the reminder. Sorry, it gives the reminder. Okay. No, sorry, it gives the quotient. Okay. This one gives the reminder. Yeah, this one gives the reminder. This one gives the quotient. Yes, okay. So now let's do some comparison. ARR1 less than ARR2. See, comparison happens index-wise, elements comparison happens index-wise, and also the multiplication happens index-wise, like this zeroth index multiplied with the zeroth index of array 2. Similarly, all operation happens, mathematical operation happens, arithmetic operation happens like that. Let me write ARR1 less than 30. So what this does is that, so in AR1 we have elements less than 30. Is it true or not? It will give. So yes, AR1 has elements less than 30. This is 10, 20 is to false. Other elements are false. Now let's do some vector product. So vector product. So number of columns of first matrix must be equal to number of rows of second matrix. This is the rule for doing matrix multiplication, as you have learned in your uh, lower classes, in junior level classes and in your 12th standard. So number of columns of first matrix is equal to number of rows of second matrix for doing the matrix multiplication. So let me take identifier A and pass an array of 1 comma 6 as the first elements and 2 comma 6 comma 7 as the second elements. And let me take another identifier or variable np dot array of 2 comma 4 as the first two elements and 6 comma 8 as the second row elements. Okay. Now let me print A and print matrix B, which is array. So let me print Okay, so we have two matrices, 1 comma 6 and 6 comma for 7 are the matrix A elements, and C 2 comma 4 and 6 comma 8 are the matrix element B elements, matrix B elements. So what we'll do, let me perform a dot product np dot of A comma B. So this performs the matrix elements like 1 into 2 plus 6 into 6, which is equal to 36 plus 2, 38. Similarly, 6 into 2 plus 7 into 4. 6 into 2 is 12, 7 4 is 28, which is equal to 52. So this is the matrix multiplication that is happening. So now let's do some other operation, uh, like sum, maximum and minimum. Let me take the array that I had already created using linspace. Okay, Control C. So let me use sum, max and min function now. Okay, let me have 10 rows over here, 10 columns, and let me have any number of rows. So we have 10 columns now, and we have 50 elements. So let me sum p dot sum of array5. So what this operation will do, sum operation will do is that the all the elements will be added up. So I mean all the 50 elements that are present inside this array will be added up, and you will give the sum of the elements. So total is 300,300. Okay. So now let's see the maximum element inside this array. Okay, so maximum is 31. This is 31, obviously. And let me see the minimum element, which has to be 20. So we have got the 21 as the answer. So what? Let's do some other operation like maximum element in within a given column. Okay. So let's see. Let's give axis equal to 0. Okay. X equal to 0 means max value from each column. From each column. So let me pass np.max of arr5. Okay, let me see what happened. Okay, we haven't passed the axis. Axis is equal to 0. So I have got the highest element from each of the column. So let me do the same operation on the row. Row wise, what is the highest value from each row? So 22, 34 are the values. So you can see from this row, highest value is 22.836. Sorry. From this is the column, right? From this first row, 22.836 is the highest. Okay. This is next row. This is 24.857 is the highest. Next 26. Next last is 31. So we have got the required answer over here. And similarly, the highest value from each column has also been extracted. Let's do some more arithmetic operation like indexing. Let's do some indexing operation on array. Before that, let me create an array with some elements inside that. Let me create a two-dimensional array t comma 6 comma 50 comma 6. Create a second array. Okay, let me see what happened. Let me create a second array. Let's start from here. 200 comma. Okay, this is first 200 comma 1 comma 87 comma 67. Let's see if there is an area divider. Okay, so let me create third row. Third row contains 900 comma 200 comma 100 comma 300 comma 890, 4, 4 contains 76, 76, 564, 89, 88, 5, 3. Let me have the fifth one and 3, 78, 6, 54, 0. Let me check if it's correct. Invalid syntax, which is invalid syntax. On comma, this is comma, this is 3 comma. Let me check that. 6. Yeah, RR6. Okay, so now we have the elements. These are the elements inside our array. So let me see np dot sum of axis sum of array 6 axis is equal to 0. So axis is equal to 0. So these all elements could add up. Axis is equal to 0 happens column wise. So all the elements of the columns, particular columns get added up. So you can calculate 9 to 1000, 100,000, 190,000, 190,000, 260, 6,267. So, okay, so it's correct. So now let's check similarly for np dot max from np dot max. Let me check np dot max. Okay, so in the column wise, we have the 900 here highest, 564 highest, 100, 654 and 890. Okay, this is working right. Axis equal to 1 means max value in every row, and axis equal to 0 means max value in every column. So now let's perform indexing and slicing operation. Okay, indexing and slicing in an array. Okay, so let me create an array A1 equal to np dot array of 10, 20, 30, 40, 50 as the elements. Now let's print arr. Let's print the first element in this array. We can access the index. ARR 0th index is the first element, so we have extracted value 10. So let me print the last element in this array, which can be done by passing -1 as the index number, which prints last element. So similarly, let's print 30, 20, and 30 as the elements. This can be done by passing the index 1 to 3, and this is how we can do. So now let's do matrix operation on this also. So now we had already created this, right? So let me pass this copy arr6 is equal to np dot. Okay, okay. arr6. Okay, so now let's extract 1 comma 67 comma 58 564 88. So try to extract this element from the array, from the matrix. I will give you some time. You can do it. pause the video and just try to solve the problem. Try to extract now 167, 564, 88 from the above array. Okay. So let me write the code for that. So print ARR6 of. So where is the element one? So element one present in the first row, so zero first row and zero first column. So it should be one and one. So now what we want, 67 is present in the first column, but it is present in the 0, 1 to third row. So let's give me a step size of 2 over here. So here from 1, it will jump to here. And I also want a 564. So from first, I want to jump it by a step size of 2. So I will step size, I will give it 2. So yeah, I have extracted. So similarly, 88 can be extracted from here to here. So this index is 2 comma 2, and this is 1. This has been extracted for now. So now what we will do, we will do some more mathematical or numerical some slicing operation on the numerical Python array. Mm, let's do some other operations like let's try to extract 88. Okay, let's try to extract this element from the array. So we'll write print rr6 of, so what is the element? 0, 1, 2, 3. So this is third row, 0, 1, 2, 3. So third row, third column, okay, 3, 3. So 88 has been extracted. So now I would say try to extract 6, 1, 200, 5, 64, 3. This row, try to extract this row. So let me extract that array6 of, I want first all the rows, but I want only the first column, right? Okay. So I was able to extract all the elements of the first column now. So similarly, you have a task, try to extract 289, 289, 300, and 87. 289, 387, 280. So you can see you have to extract this, this, and this. Okay. So this is 0, 1, 2. So we can extract this by using. Okay. Okay. So let me write row index. So I will write row index is equal to np dot array of what is the row we want? 0, 1, 2, 2, 3, 2, 1, 2, 3, 2, 1, 2, 3, 2, 1, 2, 3, 2, 1. And column index is np dot array of, so row index is 2, 3, 2, 1. Column index is 0, 1, 0, 1, 2, 3, 1. 1, 2, 3, 1 is the column index. 1, 2, 3, 1. So now let me pass np arr6 of row index, column index. Okay, okay, some problem has occurred. me check what happened. There 6 fluent column. Hold on. So we don't have to put here. It should be comma here. Okay. So I'm able to get the row and column index elements whichever I wanted. But 87 is not extracted. Instead, 1 is extracted. Should be 1, 2, 3, 1, right? This should be first column, second column, third column, and second column. It should be second column, sorry. Okay, I have now extracted the required elements. Okay. So now let's see. Now let's try to do some operations. Let me delete this. Yeah. Okay, some problem has occurred. Okay, so let me. This is markdown. Okay, this is not code. Okay. Okay, so now let's see all array. Let's try to print all array elements which are greater than 100. Okay. Okay, so we have got all the array elements which are greater than 100 now. So let's check if any array element is greater than 50. Okay, so it's giving error now. Okay. Yes, it's giving true. Let's see if any array element is greater than 5,000. Okay. No, this is giving me false now. Okay. So now let's see if all the array elements are greater than 0. Okay, it's giving 0 false because there is an element 0 over here. Let's see if all the elements greater than or equal to 0. True. Okay, now it's giving true. Okay. So now do the splitting and array. Okay, we will now split an array. So we can split the array in different ways. So let me start. Let me create an array first. 1 is equal to np dot a range of 21, 31, 33. Okay. So yeah, one let me print ARR one now. So okay, so now we have the elements. Now let's split the array into 3 parts. This can be done by using the split function in NumPy. So we use split function pass the array and let's split into 3 parts. So first part has 4 elements, second has 4, and third also has 4 elements. Now let's split the array into np.split. We can now split the array in such a way that we will have 2 elements in the first index. Okay, in the first array we just want 2 elements, and we do and after uh, that whatever elements are present inside the array, that will be moved to the second array. So 21 and 22 will be in the first array, and whatever other elements from 23 to 32 will be in the second array. Okay, so now what we will do, we will split the array in such a way that so actually, I forgot to tell you, this is 2 means 0 and first element in the first array, and from second index, the element will be in the second array. So let's split the array in such a way that 0 and till index 2, it will be in the first array, till index 5 it will be in the second array, till index 9 it will be in the third array, and remaining elements will be in the fourth array. Okay, so if 2 means 0 and 1 element in the first array, let me check what happens. NP dot is okay, so so 0 and 1 index will be in the first array, 2, 3, 4 will be in the second array, 5, 6, 7, 8 will be in the third array, and the remaining elements in the fourth array. So 2 means 0 and 1, 5 means 0, 1, 2, 3, 4, 9 means 5, 6, 7, 8. Okay, you understood, right? So, okay. So now, okay, let's do something, right? So now let's create an array. Is np dot range of 25 comma 55 dot reshape uh, 5 rows and 6 columns. Okay, so let's print AR2. Okay, so we have 5 rows and 6 columns. So we have 30 elements from 25 to 55. So now what we will do, we will reshape this into 6 rows and 6 column. Okay, so we have 5 rows and 6 column. So what we'll do, we will split this array in such a way that we will have 6 rows and 6 columns. So let's take it as 61 for the sake, and let's have 6 rows and 6 columns. Okay. So we have 6 rows and 6 columns. Now what we will do, let's split this above array into 2 parts, and we will split it in axis is equal to 0, that is row wise. So we have first array row wise, and we have second array starting from 43, element 43. Okay, so now what we do, let's split this array column wise. So for column wise splitting, we will pass it as axis is equal to 1. Okay, so now we can see first 3 elements in the first column, first array, and first 3 columns are in the first array, and last 3 columns are in the second array. So axis is equal to 1, split it with respect to columns. Axis is equal to 0, split it with respect to the rows. Okay. So now we will do the V split. So V split for split along the horizontal axis. So np dot V split of ARR2, 3. So what happens is now is we have a V split does horizontal, along the horizontal axis, it is going to cut it into 3 pieces, the 3 arrays. So now we have array 1, array 2, array 3. 3 arrays have been created in the V split. Okay. So V split does horizontal axis splitting, and H split does vertical splitting of axis. Okay. So now let's pass vertical splitting. Now let's have only 2 splits. Okay, so now we have 2 splits. So now H split does the vertical splitting, and splitting with axis is equal to H split means splitting with axis is equal to 1, and V split means splitting with axis is equal to 0. Okay, you need to understand that. Now let's do some concatenation operation on the array. Concatenation. So in case of concatenation, we need to have array of the same shape. Okay. So let's create 2 array. Array A is equal to b dot array of new dot comma Maryland the second row we will have Albany and Annapolis. Annapolis. Similarly, we'll create a V where we will have elements as elements Ohio and Arizona. And in the second row, we will have Columbus and Phoenix. Okay, so we have our array int A, int array B. So we have two arrays, two numpy arrays. Array A contains these elements and array B contains these elements. So now let's concatenate these two array and concatenate. So let me tell you, in case of concatenation, we need to have array of the same shape. Okay, here the shape of the two arrays are 2 cross 2. So let's concatenate of A comma not happen concatenate. Okay, we have to mention concatenate A comma B axis is equal to along. Let's do it along row wise first. Okay, row wise concatenation has happened. Now let's do the same operation of concatenation column wise. Okay, so column wise concatenation has occurred. So this and this New York, Maryland, and Ohio, Arizona, Albany, Annapolis, and Columbus and Phoenix. Okay, so the concatenation is successful. So now let's take another array C equal to NP dot py of, let's have Ohio and Arizona. So this. Now let's do the concatenation without concatenate of A comma C. A comma C and along the axis is equal to 0. So this is easy. Since axis is equal to 0, we have two rows. We have two columns, and here two columns, and here also two columns. Here also we have, sorry, here we have two rows, and here also we have, sorry, wait a second. Okay, first column, first row, and second row. Only one column, right? Yeah, okay. So now we have two columns over here and only one row. So we have two columns, one row. This was possible. Let's do the concatenation operation along column. So you can see the concatenation operation along the column is not visible because here it's showing value error. All the input array dimension for the concatenation axis must exactly match. But along dimension 0, the array at I index has size 2 and the array at index 1 has size 1. So because of this reason, the concatenation operation is not possible. Let's So you need to have same order, I mean same shape for the concatenation operation to occur along column wise also. Okay, so since we had two columns, but we only have here one row and there we have two rows, so there was not possible for the concatenation. So we got the error over here. So let's come to the end of the NumPy by doing iterating over. So this is the last concept that has to be taught in the NumPy numerical Python array operation. So let's create an array. Arr1 is equal to np dot arr array of add element into this array. So let's iterate over this element. Let's iterate over this array arr1. So print I. So we have got the elements in the array. So we have iterated over this element. Now, what you can do is let's try to create a multi-dimensional array and iterate over the dimensional array. Let's give it a variable name as ir2 is equal to np dot a range of 55, 60 dot reshape of 6, 6, 6 r2. Okay, so let's iterate over this multi-dimensional array. So what we can do this by replace. Okay, so we can do this by for I r2 for j. So let's check what will be. So if you print I, you can see the array, each array will be getting printed. So if you want to access each element from this, what you can do instead of printing I, you can do for j I. Now print j. Now what will you see? So we have iterated over each element present inside the array. So let's okay, let's move next. So using flatten function, you can read every element. Okay, so for I I arr2 dot flatten of. So in the flatten function, we have function called order is equal to c. You can see over here. So what happens is that order is equal to c is the default one. So we have order equal to c. C means to flatten in row major. Okay. So along the row major, you'll get flattened. So let's write order and print I. So we can see 25, 26, 27. This has been flattened along the row major. So flatten means to flatten in row major C style. So whereas F, we have F means to flatten in common row major. So we have flattened it row major like 25, 26, 27, 28, 29, 30, 31, 34. Now we will flatten it column major like 35, 31, 37, 43, 49, 55. Flatten in the column major, which is an F. Okay, so like 25, 31, 47. You can see 25, 31, 47, 43. So we have done this flat operation here. So now let's move to the next operation. So we have np dot nd iterator returns iter object. Okay. So for I in np dot np dot nd it of array2 print I. So we'll get an iter object. Okay, so this is the iter object that is getting written, but you can see what will happen if you just pass np dot nd of arr. Okay, so this is the iterator object, and this is what it is getting printed if you print iterator. Okay, this is iterator object, and we are printing the elements inside the iterator object using for loop. Okay, using for loop, we are going to print. So this was the last concept of the chapter NumPy. If you want to learn more things related to NumPy, I would say you can go and visit w3resource.com. In this website, you can, let's wait for some moment. Okay, it's taking some time. So I would like to tell you that go to w3resource.com. Here you can search NumPy over there, and you can solve problems related to NumPy. And thank you for participating in this session. I would like you to please like and share and subscribe the channel if you have liked this video session. I would like to continue classes related to data science and AI. You can visit the other tutorials that I will be uploading as soon as possible over time. So this is the w3resource.com that I was telling. So you can visit NumPy over here, and there are so many problems that are related to NumPy. So you can solve projects related to that, and you can solve basic problems, and you will be good to go. So thank you for attending the session.